The shrink-wrap modifier has got a lot of settings which can be used in several combinations for different situations. Let's start simple. Here I have a plane and a sphere which I wish to wrap this plane to. I'm going to set the sphere's viewport rendering to wire so we can better see the effect it has on the plane. Currently, this plane is not modified in any way. It still only has 4 vertices to wrap to the surface of the sphere. I'll add the shrink wrap modifier to the plane. Under target, I'm going to set the sphere as the object the plane will wrap to. Now we can see how the plane seems to intersect with the sphere. Its 4 vertices have snapped to the surface, but because this one face is the only topology available, the single face appears to be inside the sphere. If I tab into edit mode and subdivide the plane a couple of times, you can now see how the newly created vertices also move to the surface of the sphere. There are 4 wrap methods, and by default, nearest surface point is selected. And it does exactly what we've just seen. It binds the mesh vertices to the nearest point on the target object. Before we take a look at the other wrap methods, let's take a look at the snap modes. Most of the settings below are shared by the wrap methods. The snap modes change how the vertices are positioned in relation to the target object. On surface is selected by default. This means if we move, rotate, or scale the mesh, the vertices are always pulled towards the nearest point on the target object's surface. If the sphere's topology is increased, say with a subdivision surface modifier, then the object vertices have a more accurate surface to snap to. Let's switch the snap mode to inside and move the plane along the z-axis. As the plane begins to intersect with the sphere, vertices inside the boundary of the sphere will revert to their original shape, whereas vertices outside will be pulled towards the surface. Outside flips this. Any points outside the target will not change shape, and any intersecting will be pulled towards the outside of the target's surface. I'll move the plane 1 meter across in the X direction. Let's set the snap mode to outside surface. I'll also set an offset factor to 0.5 meters. Now, when we move the plane along the z-axis, we can clearly see how the vertices snap to a point around the surface, but it is always set at a constant offset of 0.5 meters. Above surface may seem just like outside surface to begin with, but the difference lies in the direction each vertex is moved towards the target. I'll return the plane to its original position above the sphere. And I'll switch the wrap method to project. We can adjust the snap mode as we could before, but the results are slightly different. For example, inside will project the mesh inside the boundaries of the target, and offset will position the result in relation to the object's face normals. A positive offset will maintain the shape, but a negative offset will change the object back to its original form as it approaches the origin point of the object. The limit is set to 0 by default, which will take into account the full object's surface. If we increase the limit, this will only affect the set radius out from the object's origin along the projected surface. Subdivision levels work a little like an inbuilt subdivision modifier. and it's most noticeable when the limit is 0 and the corners are overly stretched on the target surface. By increasing the subdivision levels, those corner vertices will be projected more accurately. The axis will override normal's direction and instead will project the vertices along the global axes. In this case, the projection has been directed mainly along the z-axis. If we select either x or y, then the direction is combined, and the vertices move along in this fashion. Negative and positive will determine the direction that the projection occurs. This is in relation to the object's own surface normal's direction. I'll tab into Edit mode, and in Viewport Overlays, let's make our vertex normals visible. You can see that they are all pointing away from the target, so this direction is positive. If we only have positive ticked, then no projection occurs because the object's face normals are facing away from the target. I'll undo this step and tick negative. Now you can see that the normals are still pointing away from the target, but the vertices have been projected along the normals in the negative direction. To demonstrate face culling, let's move the plane to a position where the target faces will be both in front and behind the target in relation to the object's face normals. We'll select negative as the direction in which the vertices are wrapped. With face culling off, all the vertices pointing away are wrapped. If I switch this to cull all front-facing vertices, we can see the effect. If I choose to cull the back-facing vertices, back will do a similar thing to inside snap mode, because the back-facing vertices are what are culled from the wrap. But when I click on invert, then this occurs. I'll reset the project settings to their defaults. Now I'll duplicate the sphere, offset it, and scale it a little. I'll then set this second sphere as an auxiliary target. This will allow you to wrap the object by projecting it onto two targets. It can sometimes come in handy, but it will also come with its own set of issues that you should be aware of. You can see how, by scaling and positioning the plane, we can get a wrap which covers both targets fairly well. Let's switch the wrap method to nearest vertex. If our sphere has a subdivision modifier added to it, then the result becomes smoother, as there are more vertices to wrap the object's vertices to. Let's switch the wrap method to target normal project. This will wrap the object's vertices to the target's own normals. And finally, as with a lot of other modifiers, you can just wrap a selected vertex group to the target, or the inverse selection of that group.